Welcome to solverfy.
A KSP of BaCrO4 is 2.1 times 10 to the negative 10th. In order to find the solubility, we have to start by writing out the equation for a saturated solution of BaCrO4. BaCrO4, solid, partially dissociates to Ba2+, aqueous, plus CrO4, 2-, aqueous. This means our KSP expression is the concentration of Ba2+ times the concentration of CrO4, 2-. Okay, now let's set up an ice table. We don't use solids in our calculations, so we can just ignore BaCrO4 here. But for our aqueous compounds, our initial concentrations are just 0. Then for our change, we have some unknown amount dissociating into Ba2+ and CrO4, 2-, and we can just call that x. So plus x for each of these, since there's a 1-to-1 ratio between them, and also between BaCrO4 and each of them. Then our equilibrium is just x for each, since it's the initial plus the change. So plugging in our equilibrium concentrations into our KSP expression, we get KSP is equal to x squared. And then we can take our value of KSP and solve for x. So x squared is our KSP value, which is 2.1 times 10 to the negative 10th. Solving for x, we get 1.4 times 10 to the negative 5th. That means that our final concentration of our products here, Ba2+ and CrO4, 2-, are each 1.4 times 10 to the negative 5th molar. And since there's a 1-to-1 ratio between BaCrO4 and each of our products, for every mole of Ba2+ and CrO4, 2-, there's also 1 mole of BaCrO4. What that means is that we have a concentration of BaCrO4, which is also 1.4 times 10 to the negative 5th molar. So this is our molar solubility in water. If instead of in water, this was in 1.5 times 10 to the negative 3rd molar Na2CrO4, the Na2CrO4 would completely dissociate to 2 Na plus and CrO4, 2-. The CrO4, 2- here is a common ion of this reaction, so it will throw off the solubility. Okay, if we write out another ice table, our initial concentration for Ba2+ is still 0, but our initial concentration for CrO4, 2- will be 1.5 times 10 to the negative 3rd molar from our 1.5 times 10 to the negative 3rd molar Na2CrO4. And the reason it's the same concentration is because there's a 1-to-1 ratio of Na2CrO4 to CrO4, 2-. Our change will still be plus x. So our equilibrium for Ba2+ will be x, and for CrO4, 2-, it will be 1.5 times 10 to the negative 3rd plus x. Okay, so now our KSP will be x times 1.5 times 10 to the negative 3rd plus x, which will be equal to 2.1 times 10 to the negative 10th, since that's our KSP value. We can make a small x assumption as long as we check it later. So we get 1.5 times 10 to the negative third times x is equal to 2.1 times 10 to the negative 10th. And we get an x value of 1.4 times 10 to the negative 7th, which validates our assumption, so we can continue. Again, because of this 1-to-1 ratio, we know that our molar solubility is just our value of x. So 1.4 times 10 to the negative 7th molar.